Hello, Bernhard. How are
Hi,
you?
Carsten. Good,
What
thank you.
do we do in this video?
Yes, so in the previous tests, I think we did benchmark an individual volume and looked at the or in the individual virtual machine with the iometer test. Now it's time to do the whole stretch cluster to see how many virtual machines we can get on it with a decent performance, right?
Yeah, we compared the same benchmark VM in a non-stretched volume with a stretched volume, and we saw there is an impact. So
Yeah.
we expect also an impact here, huh?
Yes. So maybe let me go to the next slide, which is because for benchmarking, there are a couple of tools available, and we did talk about benchmarking in our previous installation series, and that's the videos, right? So we are using vmfleet for this test. We have done it before, but we don't talk about the installation procedure. If you want to learn more, go to this video, which I highlight here. This has all the details for the installation stuff. But we also look at the numbers and compare the numbers from our previous tests with a non-stretch cluster. And this is the second video, video number 22. So there are the timelines and especially, the screenshots of the numbers which we are taking now and compare it with this result on our stretched environment. So let's switch over to your system and kick off the testing routines and have a discussion on the numbers. Yeah.
But first, let me show. You see here, we deployed vmfleet the same way we did it in the Azure Stack installation video series. There are 35 vmfleet VMs. Let's see here.
Right.
If you go down on every node, so from 001 to 0035, and for all 4 nodes, you see here the owner node. They are already running.
Okay.
And we can open one. So you see, we have already done a little bit of, no, it's in pause mode and starting free run. Okay, it's already running. It doesn't care. We go to our test file. It's the same one we used last time. It's included in the VM fleet, and I included line 4. So, but it's not active. There is a command. A double cross in front of it. Yeah. It's commented out, right? So this test will do the standard Microsoft test, 4 kilobyte test with 1 thread, 32 outstanding IOs, and 0 write with it. So it's a 100% retest, and we did that in our previous videos. So we wanted to compare the numbers. So let's do this test. I switch over to the first node, and
you may still need to unleash the brakes, right?
Yes, we have to unleash the brakes, and that is, no, let's type it. It's a clear fleet pause. And if we look in our VM, you should see
pause released.
Pause released. I think that should be new, and we should start seeing numbers here. And here they are. And this is quite impressive. We have 1.2 million 4K IOPS. Obviously, everything is read, so it's 1.2 million read IOPS and only 100, 200, 400 write IOPS. This is a pure read test.
And if you would compare it, with our previous deployment, and to be sure, right, there has been some time in between. The cluster was set up, for different purposes. So Carsten, made a new deployment of this one. But if we compare it with our previous tests, right, and it was, if you look at the numbers, Carsten, you need to make it bigger because the number is too small. You wouldn't be able to
it's too small,
see.
But let's see. Here is the most important part. We have 1.23 million IOPS, and it's roughly the same. But we the read latencies are pretty good here. We have 0.1718 milliseconds. In the previous test, it was roughly the same. The write latencies are a bit higher, but we barely have some writes, and we see these are our read queues here. They have 50, 52, 53, 54 IOs queued, and here we had a little bit more. But to be honest, this was on a three-way mirror.
Yeah.
We have only done two-way mirrors, and then we replicated them. So the read is obviously local. We don't go to the other side to get the data, right, Bernhard? So it should be maybe a bit faster. Yeah?
But as you could see, I mean, it's roughly the same, or almost the same. I mean, it's the same hardware.
The same, yeah.
So no tricks here, right?
Yeah, and we see also we have this roughly the same CPU load here. It's 74 on average. Here's also 74. So it's there are minor differences, but it's a measurement, or it's today it's Tuesday. Maybe we did the test on a Wednesday. I don't know.
Okay, but anyways, I mean that's just as a reference, right? So to prove that this is almost similar. Yeah. But we are now looking at a different setup, right? So we are changing to the same load patterns we have done in the other series and now I think it's going to be interesting, right?
Yeah. So in the other series, we got very fast rid of the 4K only read test. Yeah, there are not many customers who have such a workload. Usually you have a write part in your I/O, and I like to test 30% write, 70% read. I do that forever now, and so why don't change now? So we changed the test to an 8K I/O.
Right.
We do 8 threads and 20 outstanding IOs per thread. So that's a heavy workload with a 30% write part. Yeah. So let's just save this and look at the numbers. Let's see the VM. It should. We don't see it really. If it now it's picking up. Yeah, we see it. It's picking up the new run file. It's copying it into every VM, and let's go to the numbers. So you see they changed now. Now we are kicking up the speed again, and we are at 280,000, 320, 330,000. You notice here there's a heavy write part, right?
Yeah, so it's 30%, or at least that's the goal. But we sort of could see that this is sort of hitting the maximum, right? So the system is goes as high as it probably could with that amount of virtual machines, and there is some things that come to my mind. So read latency is still okay, I would say.
You mean this,
but the write latency.
Roughly.
The write latencies are relatively high. I would say 160 milliseconds. I mean, if I would be owner of an application, need to wait 160, 180 milliseconds. That's noticeable, right? So
and in the VM, it's I think it's even worse. You see here we are maxed out at 340, 350,000, 360,000 IOPS. We will compare it with the others test. I have a screenshot for that. But here, this is not usable.
Yeah.
And look at the queues here. We have 4,000. Roughly 4,000 IO still queued that are waiting to be worked with. So it's not usable. So let's move in the screenshot from our video. Yeah.
So comparing this with the other series with a non-stretch cluster.
Let's see here. We had 800,000.
Can you make the screen bigger? Maximize this window, or at least a little bit.
Is that enough?
I just check the frame and put it a little bit larger.
You mean like this?
Yeah.
Okay, we can do that.
That's cool. So comparing it That means we have more IOPS on the non-stretched system and less write latencies, right?
Yeah, we had roughly 880,000 IOPS.
Mm-hmm.
We were writing 260,000 write IOPS, and we had
Mm-hmm.
roughly, let's see here, what would be the average be? I would say 30, around 30 milliseconds.
Right.
And if I go over to the queues, huge
Smaller.
queues. This is also not usable, but if you compare it to this one, that's 5, 6, 7 times worse, and we have only 100,000 write IOPS. So this is too much, of course.
Yeah. So I think the next test would be to sort of get the sweet spot of this hardware or of this setup, right? So let's see what is, like a decent number of IOPS that this system can take, and then compare it again with the sweet spot on the other environment, right?
Yeah. So let me point something out. Do you see here we have all the network cards here, right?
Yeah.
And if you look at the traffic, the most traffic is done on the 2 replica adapters. So we see roughly 1.92 gigabits per adapter. So that's a replica from this host replicating the change in the volume that it's owning, and it's owning the volume with the same name. So we see here our replication. Now it's 1.5 gigabit times 2. Yeah, it's working. It's working. It's copying the data over, and our network can do more. We will see that in another test, in another video. But it's a replication. It has to write the data, right?
So so what you're saying is the network is not the bottleneck here, right? So I mean, we do have still the bandwidth, or the bandwidth that could be done is higher than the 1.8 gigabyte dish per second.
Yeah, we have over 20. So they are at the 100 gigabit network adapters. Obviously, we will not get 2 times 100 gigabit. That's not possible in this design. We saw that with a live migration in our Azure Stack HCI installation video, but we got 130 gigabit. So they are quite powerful, but we will not get line speed. But this is far, far away. So and we will see more in our next videos where we do some other nice things. But I wanted to point it out. We see our replica is using the replica networks, not the other networks, and we will see that also in other videos, because we did a lot of networking stuff to make sure that the replica is using those adapters, and other traffic is not using those, but we will see that. So let's change our I/O pattern. Should we first, let's see the 500. We have also done the 500 in a screenshot for that. Let's save that, and this will be obviously also too much for our cluster, but let's see how it behaves. We have a screenshot to compare it to.
So the calculation would be 500 IOPS per
let's go back.
times 8 threads. That means 4,000 IOPS per virtual machine.
Yes,
that means
times
we
35, right?
Times 35, that would be 140,000. I mean, we did the maths before, right? So 140,000 is the theoretical max per node, but we only get 112, 120. So, and it's sort of jumping up and down, right? So I would say still we are not.
We are far over. We are still at this. Let's say we are roughly at the same numbers we had when we didn't do any limitations on the IOs. So we are here 180, 190 milliseconds latency, and also over 4,000 writes that are still queued up. So this is much too much. But we wanted to compare it, and we have a screenshot for that, right? Where is it?
Yeah, so we did, the 500 IOPS in our previous non-stretch test, and it was fine, right? So it was, if you compare it, here you see the theoretical maximum of 140,000 IOPS per host, per node. This was reached. It was pretty stable. And we could see a very decent write performance, right, with the same load pattern. So it was sub-millisecond, which is a cool performance,
0.4, right? That's really good. And imagine we do 560,000 8K IOPS in the system, and there are 30% right. So pretty good numbers. Of course, 1 million would be better, but be realistic. Who has 1 million IOPS? So, but the most important part is the write latency here. The read latency is most of the time very good, and we have it also in our test here. We are around 0.2 milliseconds in the storage. That's not the same as we see in the VMs, but it's a measurement to see what the cluster is doing. And now look here, we are far over it. It's so 1,000 times more, or roughly, right?
Yeah. So bottom line, the bottom picture is, it is sort of, proving that a non-stretched cluster is faster and is more performant, right? So we are in the sweet spot on the non-stretched, but we are way over the sweet spot on the stretched system, right?
It's not usable. So let's start a bit lower, right? So let's start maybe with 100, or should we start with 50? Let's start with 50. Come on.
Yeah. So
we have a little bit time.
1/10, right? So
1/10 of the
IOPS.
Yeah, does he already? We have to put it here so that we maybe see if it's doing something. So now it's loading the pattern. You see here everything is calming down.
Okay. So we should see 1/10. That would mean 14,000 IOPS, right? Theoretical
roughly,
max.
True, and we have that now. Look how nice.
Cool. Okay. So the system can take it. But if we compare
hopefully it can take.
Yeah,
it can take 400 IOPS per VM. Times 35, of course. Yeah.
The read latency is excellent, but you need to make sure, or at least you see the write latency, right? So it is stretched. That means you have to transport the writes over the wire, although it is a short wire. You're still in the mechanism for a storage replica, and that adds the
roughly the 2.5 milliseconds for the VM at the right, and we see here we have also a 2 millisecond, around 2 millisecond write latency. That is already 6 times more than when we had 650,000 or 560,000. Sorry. IOPS in our other cluster. So that is, of course, one part is we have to write it twice. We have transported to the other side, of course, but we have also the log file that is slowing us down. And hopefully we will get improvements here in the future. So let's speed it up a bit, huh?
Yeah, so let's see what the maximum is the system
I doubled
could take.
it. Come on, I doubled it.
Wow.
Wow, yes. So we will see here if it catches up.
So that's a fifth, as you would say, a fifth of the IOPS of the thing that we have in a non-stretched environment, right?
Yeah.
Can you?
With very good numbers. So we should see around 28,000 IOPS per host. That's already 112,000 roughly, right?
Looks good.
And I think we are still good. We are still good here, you see.
Didn't rise too much. I would say that's acceptable. I would say we can, I think, go even more.
Should I try 150?
Yeah, go for it.
So we see already now it's picking up it faster. Okay, let's go here. So now all the VMs are loading the new pattern. And this is what I love about vmfleet. We can just change it on the fly, and a minute later, all our VMs are using our pattern, right? So we are now at 42,000. Pretty steady here. That's always a good sign if this is steady. And we have 170,000 IOPS here. And we see a 2 or a 3, sometimes a 5, but it's still it's still usable, I would say. The queues are now at around 30, 35, 40 sometimes. There are some outliers, or how you call it in English. Not so sure, but still, it's good. It's okay.
But I think we are approaching the edge, right? So you have some parts, some numbers are trying to escape from the usual, average. So this is, I would say, you don't have too much room left for. I think
let's go to 200. Let's see what's happening at 200. Okay, and then we can go a little bit. Oh, let's do half of it. 75, 175. Okay. Come on. We don't want to prolong this video too much, but the important part is we want to show that it's still has still power, but it's not the same as if we would have a non-stretch scenario. So now they are picking up speed again. So we are now at roughly 200,000 IOPS. Right. 58,000 writes, and they are steady. So look here, 2, 3, 4. Still not too bad in the moment. We are higher here. Yeah, we are in the 40s. Two of the nodes are at 60 in the moment, so we are higher. But the queues are not too far away.
Yeah, and looks good. I would say,
That looks still decent. So to really test it, we would have to run it longer, of course. But that seems still decent, I would say. Or what would you say? We are approaching 4 milliseconds maybe, but we are still most of the time below 4 milliseconds. So let's do 200, and let's see what happened at 200. So 175 was still good. At least it seems good, right? So new run file. Yeah, so we are picking up speed. So we are over 200,000. And to be honest, the write part is the important part. The read is not really the problem here. So we are 225,000. The read is still pretty, and I would say the cluster is behaving marvelous. We have 3s here, 4s. It's not running away. It's still stable in the moment. We see 70s here. We are roughly now we had a 120, but it's coming back again. 70, 50. That's still not too bad. But you see, sometimes we have higher write latencies over 10. I would say we could go now. We have a 24 here. You see, there are sometimes outliers. I think it's the right word. I'm out. But now it's good again. But I think we are at the point we can do a bit more, maybe, or this is maybe the point where.
Let's try to find the spot where it's running away. Maybe you go for let's do a 250 and then see.
You want to go to 50? That would be half the IOs we had before in our.
Right.
So let's see what's happening with 250. I would guess it's too much, but in the moment the cluster is doing nice. And we can also have a look here at the replication. It's picking up again, you see. 1 gig, 1, 2, 1, 3, 1, 4. So we have 280, 280, 84,000 write IOPS. Yeah, it's on his best behavior. Bernhard.
Well, I would say. You have some numbers jumping.
They are still decent numbers most of the time, but we see a 10, we see a 7, we saw a 14. It's going 32. Yeah, I think we are we are over it. It's not too stable. 52, you saw it, right?
But bottom line is, I would say, with half of the IOPS, right? You would say, like in a non-stretched environment, half of the IOPS is sort of at least something, you should be aware of. Don't put so many virtual machines on it, because you could sustain only maybe up to a half of it. And the other thing is, I mean, the latency, right, is much higher than than it would be on a non-stretched system.
If you compare it with the numbers we had in our non-stretched system, I still have them here handy.
Yeah.
So let's see here. You see here, we had 0.4. Here we are at, let's say, a 4 if we close both eyes. Yeah.
It's factor 10.
Yeah, so it's factor 10. So it's different. The cluster, I would say, is still kind of stable. It's a little bit over maybe. Yeah. So you can run the VMs with that I/O, but the latency is 10 times, at least, and at this layer, it's 10 times worse in the CSV layer. Yeah. Of course, the SBL layer is still golden, but that's local, I would say. The software bus layer, it's local. We have only a two-way mirror. It's even better than here. But what's important is what is really the VM seeing in this layer.
Yeah.
And there is a huge difference. And you see here, we are now out of the 4 milliseconds. Now it's back. It's too much. I would say half is too much.
Yeah, and it's also like, even, the below test, the 560,000 IOPS we had on our non-stretched, I don't think that this was the absolute maximum. We could have gone higher, I think, but that was some sort of an artificial number. But, it's
we
some
didn't want to bore our view, but bore our viewers with messing around. Usually in a real scenario, I would really try to find a good number. So I did now 160. That's roughly a third. And we will see. We still see here. You see, it's still 2, 3, sometimes 15. I would say a third is better than half of it. It's maybe not. I think it's better. A third of the IO.
So I think was that it for this video?
I would say this was it for this video. We will use vmfleet in our next videos to have workload on our cluster, and we will play around with our cluster a bit and show
maintenance,
show how resilient it is, right?
Yes. So let's, you've seen the performance implications, and now let's play a little bit and do some resiliency tests. Okay, see you in the next one.